and welcome to This Explainer. Today, we're unpacking the absolutely fascinating, kind of bizarre double life of a phrase you've definitely heard before, the quantum leap. It's literally everywhere in our culture, living this dual existence as both the ultimate spiritual promise of an overnight life transformation and the foundational, mind-bending mystery of atomic physics.
Okay, let's dive right into this, because the allure here is just incredibly powerful. What if you could instantly jump to your dream reality? I mean, think about that for a second. In the world of personal growth, the promise of a quantum leap is that you don't actually have to grind through years of slow, incremental steps to change your life. Instead, you can manifest a massive overnight upgrade. It's all about waking up in a timeline where your desires are already fulfilled. So in pop culture and spiritual communities, quantum leap isn't just about working harder or, wishing really loudly. It's defined as a sudden structural identity shift. The whole idea is that you aren't trying to force your current limited self to achieve a goal. Actually, you're completely relocating your internal identity to match the version of you who already has that outcome. It's totally nonlinear. The results show up faster because the fundamental architecture of who you are changes first.
All right, here's our roadmap for today's explainer. First, we'll look at the ultimate life upgrade. Then, the original quantum argument. Third, catching a jump mid-flight. Fourth, the observer effect myth. And finally, the space in between.
Section 1. The ultimate life upgrade. Exploring manifestation and the two-cup method. To actually put this metaphysical jump into practice, you might have seen this floating around on social media. It's a very tactile ritual known as the two-cup method. It's essentially a symbolic psychodrama. You label one cup as your current reality, say stressed and stuck, and another as your desired reality, like thriving and free. You focus your intention, visualize the new reality, and then physically pour the water from the current cup into the desired cup. This physical action represents shifting your timeline. Finally, you drink the water to internalize that new state. It's a clever way of signaling to your subconscious that a sudden, definitive jump from one state to another has just occurred.
Moving on to Section 2, the original quantum argument. Niels Bohr versus Erwin Schrödinger. Now, what's really interesting about this is that long before it was a self-help buzzword, the quantum leap was the absolute OG of quantum weirdness in the world of hard science. Back in the 1920s, Niels Bohr argued that electrons orbit the nucleus in strictly quantized, discrete energy levels. To change levels, they had to jump instantaneously and randomly without ever existing in the space between. But Erwin Schrödinger, the guy famous for the cat, absolutely hated this. He argued for continuous, smooth waves. Actually, he was so irritated by the idea of sudden, causeless transitions that he mockingly called them quantum jerks, insisting that nature doesn't just switch states in zero time. And this debate, it raged for decades. Bohr proposed the jumps in 1913, and it became a pillar of the Copenhagen interpretation by 1925. Cut to 1952, and Schrödinger is still writing angry essays attacking the concept. But the technology to actually watch a single atom just didn't exist yet. It wasn't until 1986 that scientists finally observed these jumps happening in trapped atoms. But even then, they couldn't tell if the jump took time or happened in 0 seconds. That all changed in 2019, when a team at Yale University finally managed to catch a jump mid-flight. Section 3. Catching a jump mid-flight. The 2019 Yale experiment. This is where modern scientists finally settled the century-old debate. The fundamental problem in quantum physics is that looking directly at a system destroys its delicate quantum state. It collapses the wave function. So the Yale team used a brilliantly clever trick. They monitored an artificial atom by essentially side-eyeing it. Instead of looking right at it, they watched a secondary system connected to it. One of the lead researchers compared it to a Sherlock Holmes mystery, where the vital clue is that a dog did not bark in the night. By monitoring what the atom was not doing, they gathered information without destroying the system's coherence. And what they found? It completely flipped our understanding of physics. It somehow proved both of our pioneers right and wrong at the very same time. By watching this artificial atom so closely, they realized that the jump is actually a continuous transition. It isn't instant. Furthermore, by spotting a specific pause in the data, they could predict when a jump was about to happen. And get this, by applying a pulse of photons, they could actually reverse the jump mid-flight. So Schrödinger was right. The leap is continuous and smooth. But Bohr was right too. The onset of the jump happens at a seemingly unpredictable random time. So how long does this transition actually take? Well, the Yale experiment measured it in microseconds. Now, to put that into perspective, in the atomic realm, a microsecond is an astonishingly long time. A microsecond proves definitively that a quantum leap is absolutely not instantaneous. It takes time. It is a real physical event unfolding continuously. Section 4. The observer effect myth. Separating consciousness from measurement.
Okay, here we need to address one of the biggest pop culture misunderstandings of quantum mechanics. So the crucial point is understanding what physicists actually mean by the word observer. In physics, an observer is just a measurement device, like a photodiode or a camera. It does not require a human mind or consciousness. The famous uncertainty in quantum mechanics is an inherent property of the particles themselves, not just a byproduct of us looking at them. When a particle changes its behavior in an experiment, like the famous double-slit experiment, it's reacting to the physical context of the detector setup, not the thoughts of the person running the test.
This leaves us with a pretty stark contrast. The pop science myth loves to claim that human consciousness directly alters physical reality simply by observing it, that the mind literally controls matter. But the quantum physics fact is far more mechanical. Measurement apparatus physically interacts with quantum systems, which resolves that inherent uncertainty. Now, this doesn't mean there aren't profound philosophical questions about the nature of reality and our place in it. There for sure are, but the strict physics does not claim your brain waves are collapsing electron states.
Section 5. The space in between. The structural reality of leaps.
And this brilliantly illustrates how we can bring both the physics and the manifestation concepts full circle. In physics, a quantum leap is not some magic instant in zero time. It's a rapid, continuous physical process. It's like a predictable volcanic eruption. It seems super sudden, but it's preceded by underlying structural changes. Fascinatingly, the manifestation community teaches the exact same principle. A true life leap isn't just wishing for an instant miracle. It actually requires deep, continuous structural work on your identity. In both science and personal growth, the sudden jump is really just the visible climax of an underlying continuous realignment. Which leaves us with this final, profound thought to ponder. We've spent a century thinking the building blocks of reality just pop from one state to another instantly. But if quantum leaps in atoms aren't instant and massive identity shifts in human beings require underlying structural work, is anything in the universe truly instantaneous? Or is every sudden change we experience just the beautiful, rapid climax of a continuous journey? Thanks for joining me on this explainer. Keep asking questions, and I'll see you next time.